Hello everyone. This presentation is part of the course on automotive systems under Mechanical Engineering Department at IIT Delhi. I am Priyanshu Gupta and my teammate is Navneet, and together we'll be doing this presentation on drive details of electric vehicles. The drive system is the centerpiece of a battery electric vehicle. The main function of electric drive system is to transfer energy from storage system to wheels, which is used for overcoming rolling resistance, air resistance, acceleration resistance, and climbing resistance. Comprising of the power electronics, electric motor, transmission, and battery, the drive system generates zero local CO2 emissions and delivers full torque right from the start. Include the energy storage systems, which includes the battery and ultra capacitor, then electric motor, which is used in conjunction with all the other parts to convert electrical energy to mechanical energy, electronic controller. The electronic controller is divided into three functional units: sensors, circuits, and processors. Power converters. In driving and regenerative processes, the energy flow between the energy source and the motor is adjusted by the power converter. And transmission, wherein the power generated in the electric vehicle motor is transferred to a drive wheel. The electrification of the powertrain enables locally free, emission-free mobility and driving pleasure. Long driving range needs a lot of energy if only the electric motor is used for propulsion. The needed energy is stored and delivered from a battery. Driving high motor efficiency in the drivetrain increases range or reduces the need for battery capacity. To optimize battery lifetime and manage critical situations during operation, battery management systems are monitoring and controlling all battery-related processes like charging and discharging, state of health, and cell balancing to secure the safe operation and long lifetime of the battery. Brake energy can be converted to electrical energy and stored. Purely electric propulsion delivers full torque from the start. Among different types of electric drives, there are four major types of motors that are viable for electric vehicles. And those are DC motors, induction motors, switch reluctance motor, and permanent magnet brushless motor. They possess fundamentally different machine topologies. Basically, they are classified into two main groups, the brushed and brushless, and each group can be further classified into different subgroups. So let's talk about each one of them. The first one being DC motor. DC motors are widely applied in electric vehicles because of the orthogonal disposition of field and armature. Simple control is the advantage of DC motors. The permanent magnet DC motors allow a significant reduction due to the efficient use of radial space. Due to the low permeability of the permanent magnet DC motors, armature reaction decreases under normal circumstances. The commutation has been greatly improved. Then the induction motor. Induction motors as a brushless drive are widely used for electric vehicles because of the low cost, high reliability, and easy maintenance. However, the induction motor performance is quite limited, such as the variable voltage, variable frequency control. The main reason is due to the dynamic model of the non-linearities. Recently, the induction motor has seen a great progress in the design method and the power density has increased. Next, switch reluctance motor. SRMs with a simple structure have been recognized as potential traction motors for EVs, low manufacturing cost, and outstanding torque speed characteristics. Vibration cancellation technique for the SRM has been proposed to reduce the vibration mode and acoustic noise. Then, permanent magnet brushless motor. These motors have become increasingly attractive and can directly compete with the induction drives for EVs. The permanent magnet synchronous motor and brushless DC motor are two main representatives. The advantages are high efficiency, high power density, and high reliability.
Today we'll be looking into the Mahindra Riva E2, which is one of India's first mass-produced all-electric cars and it was also the first Indian mass-produced car to have lithium-ion batteries. So, and it also has a three-phase induction motor and a range of around 120 kilometers per full charge. It also has other additional features such as regenerative braking, automatic transmission, and also uses a rear wheel drive with single motor using single speed transmission. So now we look into where the drive system of the Mahindra E2O is located. The given schematic shows the positions of the various elements which compose the drive system. So, first of all, the electric drive motor is located as shown in the figure. So, the electric drive motor is located towards the rear of the vehicle because, as we discussed earlier, the Mahindra E2O is a rear wheel drive vehicle. Uh, in, ad- uh, in addition to that, all the transmission and the differential is also located towards the rear end of the vehicle. The lithium ion batteries which power the motor are located beneath the passenger and the driver's seats. The other components, such as the battery cooling ducts, are located towards the front end of the vehicle. As mentioned earlier, the battery pack of the Mahindra E2O is located underneath the passenger seat. So the region has been highlighted in the figure. The specifications of the battery pack are shown now. This is the real rear wheel of the vehicle, and both the motor and the transmission is present in line with this rear wheel. So now we'll try to locate the induction motor and the transmission system of the vehicle, which can be seen from underneath the car. So here we have the induction motor, and connected to it we have the transmission system of the car. It is located to the rear of the vehicle, and its specifications are given as follows.
Now let's talk about the challenges and future scope of study. Short driving distance greatly limits the application and development of electric vehicles. In electric vehicles, the power supply did no progress at all. Effective use of the vehicle power supply is an urgent problem. Thirdly, torque of the drive motor, speed control accuracy, and efficiency optimization requires improvement over the entire range. Also, the motor runs under bad conditions, example, the vehicle engine vibration and high temperature environment. Therefore, the motor must be adapted to environmental conditions, should be reliable, stable, and under safe operation. Due to space limitations, high density, compact, and lightweight motors are in need.